How do plate tectonics affect polar region seismic activity? Imagine the Earth's crust as a giant jigsaw puzzle made of huge pieces called tectonic plates. These plates are always moving, and their interactions shape the seismic activity in polar regions. In the Arctic, for example, the boundary between the Eurasian and North American plates is a major spot for earthquakes. This boundary is known as the mid-Arctic earthquake belt, where the plates are slowly pulling apart. The fault lines here are complex, with different segments showing different types of movement based on the condition of the Earth's crust beneath. Some parts have rigid, solid rock, while others are weaker or more fractured, which influences how stress builds up and gets released as earthquakes. In Alaska, the tectonic activity is driven by the Pacific Plate sliding underneath the North American Plate. This process is called subduction and causes some of the strongest earthquakes on Earth, often exceeding magnitude 8 or 9. These big quakes happen where the oceanic plate gets stuck and then slips suddenly, shaking the land and even affecting glaciers and rivers nearby. Besides subduction, the Pacific Plate also moves laterally past southeast Alaska, creating side-to-side fault slips that can cause smaller but still significant earthquakes. These movements are part of what makes seismic activity in polar regions so varied and interesting. Glacial melting also plays a role in how tectonics influence seismic activity. When glaciers melt rapidly, especially in places like southern Alaska, the weight on the Earth's crust lessens. This reduction in pressure allows the crust to move more freely, which can sometimes trigger more earthquakes. This is a clear example of how climate change and tectonic processes are connected in polar areas. Overall, the way Earth's plates move and interact in polar regions creates different zones of seismic activity. Spreading centers where plates pull apart, subduction zones where one plate dives beneath another, and transform faults where plates slide past each other all contribute to this activity. The presence of ice and melting glaciers adds another layer of complexity, influencing how stress builds up and gets released. Understanding these processes helps us better predict and prepare for earthquakes in these cold, remote parts of the world.